Okay. In this video, we consider the application of Kirchhoff's rules. And for that, we consider an arrangement called Weisstein's bridge. Now, Weisstein's bridge means this is the bridge arrangement. 4 resistors P, Q, R, and S, the form of a quadrilateral, and connecting B and D, there will be a galvanometer. Actually, this galvanometer is bridging the path ABC and ADC, and the supply is given at our 2 points. Okay. Now, here we are applying Kirchhoff's rules to find the condition for balancing of the bridge. So, we are applying Kirchhoff's rules for finding the condition for balancing of the bridge. So, what is meant by balancing of the bridge? Actually, here 2 paths are there, and this is the galvanometer path that is bridging the 2 paths. Balancing means potential at B and potential at D, when they are equal, potential at B equal to potential at D, then we say the bridge is balanced. Means both the points are at the same energy level, then it is said to be balanced. If that situation is obtained, no current will be flowing through this path. Here a current is flowing through this path because we have taken the condition VB greater than VD, so it flows along this way from high energy to low energy. Okay? So, how we can obtain this situation? Balancing of the bridge. For that, we have to arrange or adjust the values of P, Q, R, and S. So, how we can adjust the values? There must be some mathematical formulation possible. That is what we are going to find based on what? Kirchhoff's rules. Okay. Now, already it is set here. Connecting, there will be a current I coming towards A, and IP flows through the resistance P, IR through R, and condition we assumed here VB is greater than VD, therefore the current which is reaching here, that is IP, is getting splitted into 2 parts as IG flowing through this galvanometer and remaining I minus IG flowing through this way. And IG reaches here, same time IR also reaching here, that comes out through this as IR plus IG and meets at this point, flows out as I. So here we have taken Kirchhoff's first rule called junction rule. Well applied that junction rule, how the currents are splitting and adding and all that. Now we are going to apply Kirchhoff's second rule to get the condition for balancing of the bridge. That already I told you the adjusting will be based on, or the balancing will be based on P, Q, R, and S, the resistance values. Now, if all these 4 resistors are to be included, then we have to consider loop rule accordingly. If you consider this whole circuit here, there are many loops you can consider, but all that is not necessary. So what is necessary? Only that we consider here and to get the condition. As all the 4 resistors are to be included, remember you have to consider 2 loops only, that is A, B, D, A. That includes P, galvanometer resistance, and resistance R. Like that, second group B, C, D, B. That includes Q, S and galvanometer resistance. That is enough for finding the balancing condition. Okay. Now I am considering the first loop from, that is loop A, B, D, A. By now, all of you have understood the sign conventions and the writing of the equation and all that. So I am directly writing all that thing. Minus IP into P minus IG into RG, where RG is the galvanometer resistance. Then reaching D, coming back to this, you will get plus IR into R equal to 0. So that you get IP into P, then plus IG into RG equal to minus IR into R. Okay? Got it? Let me say this will be equation 1. Like that, if you consider the loop, which one? B, C, D, B. B, C, D, B. B, C, D, B. You get minus IP minus IG into Q along the direction of flow plus IR plus IG into ES, then plus IG into RG equal to 0. Along the direction, against the direction, again against the direction. Okay. Now here you can see IP minus IG into Q, then minus IR, minus sign is right, then this becomes negative, will be equal to IP into P plus 1 minute. Here this will be what? Plus. And here minus, this minus, and this will be IG into RG. Got it? So here already we have taken the negative positive, and therefore this will be as it is on the right hand side. And here this will be coming like this. And this, let me take it as equation number 2. Okay? Alright. Until this is clear. Right. Now, suppose that the bridge is balanced. If the bridge is balanced, how we can identify that? Potential at B and potential at B are equal, that no current is flowing through this B. That means when the bridge is balanced, this is understood from the galvanometer reading that the galvanometer reads 0. So when the bridge is balanced, by arranging all these things, then we can say IG equal to 0. So from equation 1 we get IP into P, and this will be what? 0 equal to IR into R, equation 3. That means IG is 0. Okay? That's from the first one. Now like that, if I apply the condition for the second equation, you get IG equal to 0 here. Here also 0. And therefore we get what? means IP into Q. This is 0. Then minus IR into S. This is already 0. So this minus IR into S, I take it on the right side and you say IR into ES. Equation number 4. Yeah. So I applied the condition already that the bridge is balanced and galvanometer current is 0, and if that is the situation, this is equations 3 and 4 defines that. Now from 3 and 4 we can arrive at a mathematical relationship between P, Q, R and S as equation 3. Just divide. We get P by Q equal to R by S. P by Q equal to R by S. If these ratios are equal, then understand that the bridge is balanced. Okay? Understood. Now here one question possible is that once the bridge is balanced, if we interchange the position of the galvanometer and the cell, what change is possible? That's a question possible. Means once the bridge is balanced and then you are interchanging the galvanometer and the EMF. Let us try that too in this one. So here what comes? EMF, and here it will be galvanometer. I am not going to the other part of the theory and all. You can see when it comes like this, the ratio will be galvanometer, let me say like this. Just to understand, galvanometer is connected like this, and the EMF will be connected across these 2 points. Then it comes Q by S is equal to P by R. What comes as Q by S is equal to P by R. And what it is, again the same. Goes here, or take this to this way. You can see R comes over here R by S and Q goes over here P by Q. Same thing on P. So once the bridge is balanced and then you interchange the position of the galvanometer and the cell, actually there is no change in the condition. The ratio of the resistors must be the same again. Okay? That's all for this video.